What's perimeter? The distance around the shape, right? So perimeter is one thing. What's area of a shape? Like the inside, the space inside, right? Okay, so what we're going to be doing is figuring out how perimeter and area relate to each other using these two triangles that you see here. Okay, so look at this first triangle. Can you tell me the perimeter of this green triangle?
What would it be like?
How'd you get 12? Right, 3. Oh, I should do this in the same color. 3 plus 4 plus 5, right? So 12 is the perimeter of that first triangle, the green one, okay? Then we go to this triangle. Oops. Okay, if we want to find the perimeter of the blue triangle now, what's that going to be? Add it all up. 6 plus 8 plus 10 is 24. Okay. We're going to pause there. We're going to talk area. How do you find the area of this green triangle? It's not base times height. What's the area of a triangle?
You add the two together now.
Max, put that away. Area of a triangle is 1/2. What?
Oh.
Base times height, right? Area of a triangle is 1/2 BH. So if I want to find the area of this green triangle, what's the base and what's the height?
Half times 3 times 4.
Yeah, the 3 and the 4. So 1/2 times 4 times 3 would mean the area of that green triangle that would be 6 square units, right? So the area of that green one is 6. The area of the blue one then, area equals 1/2. What's your base and what's your height? 6 and 8, right? The two that are perpendicular. Your base and height always have to be perpendicular to each other. So 1/2 times 6 times 8. So that would be 24. Okay. Now think back to, oh man, what section did we do that in?
Never mind.
You good?
Yes.
Okay. We have 3 different things going on right now, okay? I want a scale factor, I want a perimeter ratio, and I want an area ratio. What is a ratio?
Like a rationalization.
Anytime now.
A what? Who said that? Something to something. A comparison, right? A ratio is something over something. You're comparing numbers. Okay. So a scale factor is a ratio, something over something. Do you remember how to find a scale factor for 2 figures? Do you know the scale factor for this figure to this figure?
2. Oh. Is that this Bermuda?
Okay. So you could say 2 over 1, but you always do it in the order it's given, right? So like 3 over 6 or 5 over 10, right? Or 4 over 8, right? So listen. Shh. Hey, you can talk about it later. So your scale factor is just the comparison of your sides, right? Your scale factor in this case, what would this reduce to, all 3 of those?
2 over 4.
All the way down, as reduced as you can go. 3 over 6, all of these are 1 over 2. Okay, so your scale factor for those 2 triangles is 1 to 2, right? You just pick one side, find the corresponding side, and make it a ratio and reduce it as low as you can go. So the scale factor is 1 to 2. Okay, then we want a perimeter ratio. Well, we found the perimeter of the one and the perimeter of the other. So if it's 12 to 24, what does that reduce to? 1/2, 1 to 2. Okay, now look at your areas. You had 6 and 24. The area ratio, 6 over 24, what does that reduce to? 1 over 4. Okay, so here's what I want you to see. A scale factor is just a comparison, this side to that side. A perimeter ratio is add up all the sides, and compare them. An area ratio is find the area of the figure, and compare them, right? But there is a relationship between all three of them. What do you notice about these three? 1 to 2, 1 to 2, and 1 to 4. What do you observe? Just give me an observation. Any observation.
1.
They're all fractions.
Bottoms are all even.
The bottoms are even numbers, okay?
1.
1 what?
They all have top 1.
Oh, they all have a 1 in the numerator, okay? How about the fact that the scale factor and the perimeter ratio are identical? That will always be the case, okay? Your scale factor and your perimeter ratio will always be the same. Always. There is no other option, okay? Look down here, okay? This is the setup. This is what happens. If your scale factor is A over B, then your perimeter ratio will be A over B. Your area ratio will be those numbers squared, okay? So scale factor is A to B. Perimeter ratio is A to B. Area ratio is A squared to B squared. Okay, if you can remember this, then the rest of this lesson is pretty straightforward. Your scale factor and your perimeter ratio are identical. Your area ratio is just squaring those numbers from the scale factor. Okay.
I was just writing down whatever you were writing. Like, I don't get it.
It'll make sense once we do it with numbers right now. Okay. Turn around and then you won't know that they're staring. Okay, so here's the setup. This says these two figures are similar, and we want to find their perimeter ratio and their area ratio. Now, we don't have, do you know the name of this shape? A trapezoid. We don't have, good job, enough information to find the area of a trapezoid. Remember area of a trapezoid? Don't write this down, okay? Just watch. Don't write. Area of a trapezoid was base 1 and base 2 and the height, okay? We only have one of those numbers. Therefore, we cannot find the area of this figure. But we can find an area ratio. Max.
So, we're not going to do like stupid math?
Stupid math?
The math that you have to like...
You're not going to do the formulas right now. You're not going to plug into an area formula. You're going to just use what we know. Okay, so if these figures are similar, and this is a length of 6 and this is a length of 9, can you tell me the scale factor? 6 over 9, but then we always, remember on that last quiz, you guys all forgot to reduce that, right? You always reduce. So if our scale factor is 6 over 9, what does that reduce to? 2 over 3, right? Divide everything by 3. You get 2 over 3. Okay, so here's the deal. You've done the hard work. The rest of this is simple. Your scale factor is 2 to 3.
Do we write this down now?
Yes, start writing this down. I just didn't want you to write all this down. Okay, scale factor is 2 to 3. Truett, do you need to move? Stop talking. The perimeter ratio.
Wait, so like that one on the bottom, would it be like SF 6 over an 8, and then it'd be like,
No, don't go there yet. That's a totally different type of problem.
okay.
But yes, your scale factor would be 6 to 8 and you reduce it, but we're not gonna go there yet. Okay, so we have our scale factor, right? This is 2 to 3. So what is the perimeter ratio? 2 to 3. Okay, once you've found your scale factor, your perimeter ratio has to be the same thing. Then you find the area ratio. What do you do to find your area ratio? Square both parts. So this is going to be 2 squared to 3 squared, which is 4 to 9. Okay, so scale factor of 2 to 3, perimeter ratio of 2 to 3, area ratio of 4 to 9. So they're just saying, how do these figures compare in terms of their area or their perimeter or just the length of a side, right? We've not found an area. We're not going to find an area on a problem like this. They just want the ratio. So if it says, give me the perimeter ratio, give me the area ratio, leave your answers as a ratio. Okay. Then they'll get, you know what? I'm going to give you another one of those that you're going to tell me. You don't have to write this down. Don't write it down. Let's say you have these 2 triangles.
What are you guys giggling about?
I just go see my friend.
Okay.
He's sitting
Oh, my word. What? Look at this setup. What is your scale factor? It is 2 over 8, but it's better written as what? 1 over 4. So your scale factor would be 1 to 4. What would your perimeter ratio be? 1 to 4, the same thing. What would your area ratio be?
1 squared to 4 squared.
1 squared to 4 squared, which is what? What's 1 squared?
1.
1. 1 times 1 is 1, right? So 1 squared is 1, 4 squared is 16.
That's oddly easy.
Oddly easy.
There's just a
Oh,
little
she's
bit
scaring
of
my
steps in
friend.
it.
Yep. What are you doing right now?
That's not on the paper, so if I'm supposed
No,
to
I
do
know.
that-
No, I said don't write this down. I said don't write this down.
Yeah, I'm not writing it down.
I know, but why do you keep turning around to like look at him? What? Okay, well just stay with me. Okay, here's where it gets fancier.
Fred?
Okay,
Wait, 8?
here's why you need to understand this. Excuse me. Stop talking. Pay attention. This one, they don't give you enough information to find the area of a parallelogram. Area of a parallelogram is base times height, right? They give you a base, they don't give you a height. So we cannot find the area of this parallelogram. How we know how to find it? Stop. You're being weird about it. Nobody's staring at you. Move on. Okay, so here's what you're doing. If they give you an area of one of them, so the area of this parallelogram is 96, you can actually find the area of the other one just with the information that we have here, because we have a comparison of the 2 figures. So here's what you have to do. You got to think through. We can find a scale factor, and we need an area ratio. Okay? Can anyone tell me the scale factor of this setup?
Wait, it's 6 over 8.
It's 6 over 8, which is 3 over 4, okay? Now, hear me. If you don't reduce it, you get very big numbers. Reduce your fractions, okay? If you reduce your scale factor, you will never have to reduce your area. True it. Stop.
Wait.
Use your station.
Oh.
He doesn't need to. It was not important. So if your scale factor is 3 to 4, then what is your area ratio?
3 to 4.
No, your area ratio.
Oh.
6. No, 9.
Oh, you skipped
9.
one.
I know, because we don't need perimeter, because they didn't ask us about perimeter.
4
9 to
squared,
16.
9 16.
Area ratio would be 3 squared to 4 squared, which is 9 to 16. Okay, now here's the deal. If I know the relationship between these two parallelograms is 9 over 16, their areas, I can set up a proportion to figure out the area of the smaller one. Because if it's a comparison of 9 to 16, and I know 96, I can put that in the other ratio and put x as my unknown, and then just cross multiply and solve. Where would that 96 have to go? Top or bottom?
Bottom.
The bottom. Why, Luke? Well, so here's the deal. If it was 6 to 8, the area ratio is 9 to 16, right? The bigger one has to be with the bigger one. So this is the bigger area. It needs to be with the bigger of these two. So if it's 9 to 16, I'm going to put the 96 here. What am I putting on top?
We don't know.
We don't know. What do we put for an unknown? X. Okay. So this is the setup. Once you get X, you're done with the problem. How do you solve for X?
Oh.
You cross multiply. So 9 times 96 is 864. You set that equal to 16 times X.
16x.
And then how do you solve that?
Divide by 16.
You divide by 16. So 864 divided by 16 is 54. Now here's the question. 54 what? What did we just solve for?
Inches
squared.
Inches squared.
Good job, Luke. Inches squared, because we solved for an area, right? So 54 square inches would be the area of that figure. Does that make sense? Okay, let me tell you where everyone makes the mistake on these types of problems. People set up the ratio as a scale factor, right? Oops, 3 to 4. And then they try to set up the proportion from 3 to 4. If you're working with area, you have to have an area ratio. Okay? Make sure you find an area ratio before you move on. Let's see if we can put this together with a bunch of words here. Okay, so this one says a group of high school students cultivated a plot of land and harvested 13 bushels of vegetables. So a plot of land, right? Here's their little garden. They harvested 13 bushels. Would you say that's a perimeter or an area?
Area.
Why?
It's filling up that area.
It's filling up the space, right? You would put 13 bushels in here. So 13 is an area. Okay. It says next summer, the city will let them use a larger, similar, so proportional plot of land. In the new plot, each dimension is 2.5 times the corresponding dimension of the original plot. Whenever you see the word dimensions, scale factor, okay? Your dimensions are your scale factor. So if the setup is I had this plot of land and now they're gonna give me a bigger one. If this length was 1, what's the length of the other side? That's awful, sorry. Let's just write this nicer. Okay, so the area of this one's 13. If the length of this side is 1 foot, let's say, then what would the length of this side have to be? If our dimensions are 2.5 times the corresponding. 2.5, right? What? Yeah, 2.5 times as big. So my scale factor right now for this problem is what to what?
1 to 2.5.
It's 1 to 2.5. Okay? If this is an area, we need an area ratio. How do you get an area ratio?
That looks like it is the area ratio.
No,
That's the scale factor because it's just lengths. What do you do to get an area ratio?
Oh, 1 squared.
Base.
Mm-hmm.
1.5 squared.
Yep, your area ratio is going to be 1 squared to 2.5 squared. Okay? So if you plug that in separately, 1 squared is 1. 2.5 squared is 6.25. Okay, so this is your area ratio. You're going to set up a proportion. I'm running out of room here. Okay, 1 to 6.25. Can anyone tell me where the 13 goes?
Nice, how fast you can go?
Top or bottom? Isaiah, stop.
I'm just asking.
Top speed or low?
Why?
Average.
It's the smaller one, right? It's the first one. It goes with the 1, right? The 1 is associated with the 13. The 2.5 is associated with the bigger area, okay? So, Max, stop talking. So it's 13 over x, right? Our unknown.
It's like after football games.
Stop talking.
That makes sense.
We're doing math.
That makes it worse.
Hey, knock it off.
I'm sorry.
You're not, or you would have stopped the first time I asked. Okay, so cross multiply this, and you get x equals, so go 13 times 6.25, and you get 81.25. 81.25 what?
Bushels.
Bushels. This is what you harvested.
Like, see how many bushels they can fit into a pot.
Well, do you want to buy a bunch of bushels? Like, before you know how many you need, you're going to spend all this extra money. This helps you figure out, here's how many we should buy
What you do
so we could harvest the right amount.
a certain amount that you think will fit in there.
No, what you do is you calculate how many will actually fit, and then you buy that amount.
Well, that's what math people do.
Yes, that's what we're doing. We are math people here.
How do you know about that?
Okay, last thing.
I'm like, what?
Last thing. And this one's backwards, okay? You have to reverse your brain. Shh. Xavier. On this last one, it tells you the area of 2 similar triangles. So you are given areas. Have we been given areas yet?
Yes. No.
Not both of them, right? We've been given one area and how to find the other. This time they gave us both areas, and they say, what is the area ratio, what is the scale factor, and what is the perimeter ratio? So can you tell me right now the area ratio? If it says,
50 over 98.
yes, it's 50 over 98 is an area ratio. What do you always have to do to a ratio? Not yet.
Oh,
Divide. I mean,
Reduce, right? We have to reduce first. Okay, so 50 over 98 would be 25 to 49. Okay, so now let's think about this. We said you have a scale factor, you have a perimeter ratio, and you have an area ratio. Okay, this one is given, the area ratio, 25 to 49. What did we do to this scale factor to make it area? How did we get from scale factor to area?
divide. Or reduce it.
Just in general, like the rule up here, right? How did I get from this to this? We squared it. Okay, think backwards then. If I'm trying to get from the squared version, 25 to 49,
Oh, so it's 5 and 7.
yes, what did you do?
I just like divided by 2.
You didn't divide by 2.
Well, half of it. Well, no, a square root of
You square rooted them, right? Because if this is a to b, and this is a squared to b squared, if I want to get to this, I have to square root both parts, right? So you're going to square root and square root. The square root of 25 is 5. The square root of 49 is 7. So your scale factor is 5 to 7. You square root. What's your perimeter ratio? 5 to 7. Okay, scale factor and perimeter are always the same. Perimeter ratio is for sure the easiest one. Okay, I'm gonna give you one more of those. It's quick. Let's say your area ratio is, let's see, 3 to 27. Okay, if your area ratio is 3 to 27 and I want a scale factor and I want a perimeter ratio, what's the first thing you have to do before you square root it?
What else do I do?
3 over 27.
Oh,
You
divided.
can't. You have to divide first. You have to reduce it, right? So if it's, yes,
Oh.
3 to 27 is 1 to 9. Okay, so 1 to 9 is your area ratio.
1 over 3.
Yes, good job. So you're gonna square root to get up here. Square root of 1 is 1. Square root of 9 is 3. What's your perimeter ratio?
1 over 3.
1 over 3. Okay? You good? Does that make sense?
C.
Okay.